Hey guys, let us start today's technical talk. Today's speaker is Thomas Crandall Gilbert. He's a postdoc at Cornell Tech. He previously earned an interdisciplinary PhD in machine ethics and epistemology from UC Berkeley. His recent work uses reinforcement learning to design more responsible and robust capabilities with unprecedented AI systems. And this work has concrete implications for the design of automated vehicles whose behavior is safe, equitable, and accessible to distinct subpopulations. Thomas, please continue.
Okay, thanks for that. Can everybody hear me okay virtually? I'm gonna assume that's a yes or get a thumbs up or something. Okay, so yeah, I will be discussing some of my recent work in the AV space. Not everything I do is about automated vehicle policy, but that's one of the most concrete applications of my research. As was introduced, I'll be describing this kind of methodology I've been developing across a few of my research collaborations recently that I think is making tractable some problems that are already on the horizon for what AV fleets are doing or will soon be able to do in terms of their capabilities, much of which we don't want, some of which we do. And what we want to do is establish technical means of controlling for those things and optimizing them ideally in the public interest. I guess I can say as well, I'm comfortable taking questions throughout. So if anybody wants to just speak up or raise their hand, that's fine. And I can clarify whatever it is that I've said that is not being understood. So I'll start with, okay, there's a slight delay, that's fine though. Basically, I've been thinking a lot, the theme of my PhD research a lot was how do we think about safety with respect to automated vehicles. I was coming of age as a researcher when trolley problems were still considered kind of like the state of the art for how it is that we think about the ethics of what automated vehicles should or shouldn't do. So the way those are set up, if you guys are familiar with that or not, is there's some kind of moral dilemma situation where the car is faced with who should it hit or how should it swerve in order to minimize damage or maximize some notion of the good. I always thought those thought experiments were quite contrived, partly because it always seemed to me like the more interesting questions and the more structural questions that were going to play out over the long term were about how it is that automated vehicle fleets are going to transform cities, transform how it is we get around cities, how do we get from point A to point B, but also how do we think of ourselves as consumers of public infrastructure. And so I'm giving on this slide just a few examples of both recent developments with AV fleets. So on the left, we have the kind of recent, fiascos of like cruise vehicles in downtown San Francisco that are kind of milling about these intersections and clogging up traffic and making it very difficult for other human drivers to get by. But in other senses, fleets have other sorts of dynamic effects on road infrastructure. The most obvious being that roads are not infinitely usable. They have to be repaired. If they're not regularly repaired, and if they're used in exactly the same way over and over again in particular places, you are going to wear down parts of roads, generate potholes, signage might be eroded. You can't take that material aspect of roads for granted. And then finally, and on the right, this is a little more abstract, but I think it's really important because we already saw this happen with cars 100 years ago when they were first deployed, is that whenever you are deploying a new means of transportation, you are implicitly also redefining every other way in which roads can be used. So the example here I give in this image is basically you think of jaywalking. Jaywalking didn't exist before cars, right? So before cars, pedestrians could just use roads however they wanted because roads were public. And it was assumed that if you wanted to play hopscotch in the middle of a road, you could do that. Once cars became the default means of transportation, that calculus shifted, where suddenly the burden was placed on pedestrians, cyclists, horses, anybody else that wasn't a car to conform to these new implicit or explicit rules of the road. So what these examples, I think, have in common is they're showing how what is really very likely, frankly, I think inevitable from the standpoint of autonomous vehicle fleets, is that they're going to redefine the dynamics of roads around themselves, okay? So at a certain point, the question stops being, how do I make a car safe enough to deploy, and starts being, how do we make roads safe in light of the disruption that our fleet is going to create on them. And that includes things like safety then starts to include a wider range of values: equity, mobility, efficiency, economic utility, all sorts of other values become folded under safety. Because if you don't, you're going to end up making roads less safe as a whole, even if your fleet doesn't hit anything. Even if your cars don't themselves physically collide with any object, they could wear down roads, they could make roads harder and harder to use, or they could implicitly make it so that people use roads differently over time in ways that may very well not be socially desirable, and can be traced back to the way your fleet behaviors have been defined or the constraints have been encoded. Any questions about that framing?
I have a question. So in terms of like you're it sounds like you're shifting the metric actually from safety to social desirability. Those are not the same metric though, right?
They're not the same metric, but what I'm arguing is that ultimately they're correlated. And ultimately, I think social desirability gets folded under safety in ways that are implicit and that are actually very difficult to define a priori, but that we could investigate, that there are research methods by which you can make that tractable, but I think that largely has not yet been done.
Okay.
Yeah. Okay, so I'll jump ahead to the kind of too long didn't read slide for this presentation, which is what I'm doing, which is I think that part of the solution here is that if we think of the different methods, both qualitative and quantitative, by which AV capabilities can be designed, then it's possible for designers to specify which of those capabilities are desirable or not, even if they don't yet exist or can be corroborated in terms of what roads can support right now. So rather than relying exclusively on simulation or exclusively on some kind of human factors approach or a user-facing approach in order to validate safety criteria, if we interrelate these methods in the right way, we can get ahead of these problems in a way that makes them tractable before they become encoded into infrastructure in a way we can't stop. This is the big danger, again, from what happened 100 years ago, because it basically became the paradigm where we started to design roads for cars rather than for people. And so you think of things like highways, bypasses, interchanges. Technically, those are public infrastructure, but they're really kind of not, because you have to have a car in order to use them. Any other kind of road user can't use them. So what we need to do is find a way to combine the methodologies at our disposal, research methodologies, so that we build out the infrastructure we want at the same time we build out the kinds of fleet capabilities that we want, like to coordinate these things in a meaningful and desirable fashion. And I do think we have the tools in hand to do this, but it does require a different kind of a frame on what progress looks like from a simulation standpoint and then also from the user standpoint. And I'll go into, this is the rest of the presentation, is explaining what this means. This is the slide that I'll kind of keep returning to over the course of the talk. So the way I think about this mixed methods approach is that we should start to really explicitly think about the way in which qualitative and quantitative metrics or methods are related to each other is in terms of a feedback loop. So when we think about a fleet that is technically safe, okay, it doesn't hit anything, but it might drive in ways that are counterintuitive or alien or anxiety-inducing for humans, that will make them feel uncomfortable in ways that ultimately will feed back onto the performance of the fleet over time. Vice versa, you could think of a fleet that is, or a vehicle that's very comfortable to use from the human standpoint, but that for some reason is extremely inefficient or suboptimal against a certain planning horizon, whether that's like at the city level, at the state level, something about the scale on which the fleet is intended to operate is not well coordinated with the user experience. So a lot of what I've been trying to do over the last, I would say like 18, 24 months at this point, is start to deliberately construct research papers and methods that set each other up for success to test on variables or features of roads or cars that, even if measured qualitatively, can then be encoded in simulation in a way that the results of that can then be fed back into future qualitative studies. so that you get this meaningful coordination between these two different approaches rather than just having them act in parallel to each other. And I think the parallel track vision, where these are just sort of two straight lines that are progressing individually but not coordinated, that's actually not going to be successful in the long term for the reasons I was outlining on my first slide about, like, you get this clogging behavior of traffic, you get these other kinds of problems. There needs to be a way to make it so that these different lenses we're using make us able to see the fleets that we're building in a way that will actually work for people in ways that they want, and not just in ways that are conforming to whatever is required by law. So what I'm going to do for the rest of the presentation is just take us through this feedback loop as it's reflected in these different research papers that I've been developing. I'll start with this paper, or this lens rather, which is what I'm calling Sociotechnical specification. So this work was published at ICRA in May of this year at this workshop, the Fresh Perspectives on the Future Autonomous Driving workshop. So this is one of my dissertation chapters actually originally, but this was co-authored work with Aaron Snoswell, who's a postdoc in Australia, Michael Dennis, who's finishing his PhD at Berkeley, Rowan, who is at TRI, and then Kathy Wu, who's a professor now at MIT. And the goal of this project was really to begin to develop an aspect of the lens I've already been proposing, which is when we're building automated vehicles, if we're being kind of, I think, conceptually honest about what that means, we're not so much automating driving as we are automating components of the transportation system itself. Okay. So rather than thinking like, oh, computer vision has now reached the point where we have cars that can have eyesight at the level of an individual human, think of that more in terms of, oh, we've now developed a new kind of transportation system component that once integrated will change the way that this aspect of mobility interfaces with these other parts of how cities operate. So you have to think of the transportation system as including many of these different parts at the same time that it itself affects these adjacent features of what cities are, what social reality is. So I give some examples on the slide. Basically transportation systems enable us to get to work. They inform how our economic activities manifest. They impact the external physical environment. They affect how it is we are socially mobile over time. Transportation is highly correlated with the housing market. And of course, it's corroborated and built through public infrastructure. And so what we do in this paper is, like, after we outline this kind of ontology of how these components fit together, is we focus on three of them here: social mobility, public infrastructure, and environmental impacts, to ask, okay, how would we design AV fleets to be robust to and control for their effects on each of those things? Like, what are the metrics we would need in order to even measure what the impacts are, let alone improve them over time on those, at least those three components that are outlined in, I think that's like a burnt orange color there. So at a high level, I won't go into all the detail here, but what we do in the paper is focus on, we kind of delineate different dimensions of each of those components in terms of features that are what we call technical, socio-technical, and social. All that means is technical is basically to say all someone needs to do is literally just encode the feature into the route optimization algorithm. Okay, so basically there's already metrics in place. For example, how many food deserts there are over a given physical geofenced area, or how many there would be likely to be over time. We can actually just implement a constraint for that, such that the fleet, in theory, could be optimized to minimize on that score to whatever metric is desired. Sociotechnical is something more like there are legacy metrics that already exist in other fields, other disciplines, for how to measure the thing we're concerned about, but they have to be translated into the stack in a way that would work. And there's some parameterization that needs to happen there of, like, we don't yet really know, or the law doesn't require what is acceptable there, what is required, what considerations need to be factored in. There's some translation work to be done. And then social just means there is not even yet a consensus in any research domain or in public policy on what we want that component to look like. So this table here just gives the example in the paper of how we trace out each of these things. And for the sake of simplicity. I'm just highlighting three of them here. So we focus on the social features of two of these components at the top there, public infrastructure and mobility, and then one of the sociotechnical ones for environmental impacts, which is induced demand. Basically, how is it the fleet, once deployed, will change the likelihood of more and more people wanting to use roads on a more regular basis. And through a kind of very exhaustive literature review and translation work, we then assembled some metrics for each of those features. So what we started to do in this paper was precisely this translation work I'm describing, of like, it's true that we don't yet know how it is that automated vehicle fleets will literally induce demand, say in Houston versus Boston or in different parts of the Bay Area. But what we can do, and in this appendix, we actually describe many more metrics that could be interesting to us, is outline many metrics that are going to be correlated with those effects that other fields have been monitoring for decades: transportation planning, urban design, environmental engineering, many subfields. And basically, these are things that could be tracked if the fleet manager wants to, in order to evaluate what are the real-time or likely effects of our fleet behaviors on these features over time. Maybe during the Q&A at the end, I'd be happy to describe some of this in more detail. There's many more metrics that we factored in here, but this is really just a first attempt to kind of stake out the horizon of all of these effects and try to make them measurable rather than just allow them to be just uncontrollable externalities of your fleet that just sort of happen as a natural, quote unquote, byproduct of its operation. So that's basically this first paper. And to return to the graph I showed you, what this paper was explicitly what it was trying to do, and what I'm now comfortable saying is like part of the wider vision, is that it was really meant as a translation exercise between the more qualitative aspects of evaluating what AV fleets are going to do into something that is encodable, into something that can actually be factored into real metrics, actual parameters that you could, at least in principle, optimize on in order to guarantee a certain level of fleet performance against whatever time horizon you're concerned with. Any questions about this so far? Okay, so as you can see, we've only gone over half the feedback loop. So if it's really a loop, we have to keep moving. And that's in fact what I've been doing. So more recently, and this is work I should say that is not yet published, but I think it's close. So it's been revised and resubmitted now a couple times. This is collaborative work that I'm now doing with Wendy Zhu at Cornell Tech. So Wendy Zhu is a kind of researcher she's a professor who works on interactive design. So she's on the much more kind of human-facing side of like how it is you would make robots that twitch or get nervous or otherwise express emotions or behaviors in ways that are sensitive to humans. Or makes humans care about them. And what I was really curious to work on with Wendy was the other half of this equation. Like, it's one thing to come up with lots of metrics that once they're made really precise, could actually control for these effects. But would people want that? Would people actually want to interact with vehicles or with fleets that are then optimized on those metrics? What would that look like? How would roads feel once these fleets encode lots of metrics about controlling the way traffic moves, regulating which cars can exit at certain moments, making sure that environmental effects and pollution are minimized at the street level or not? How do people feel? And so what we did in this paper was basically construct, and I'll show you examples of this, vignettes, traffic situations of different kinds for people to be surveyed on. So it was a Mechanical Turk study. I think as the previous slide showed, we showed this to like 1,200 people through Mechanical Turk, these different traffic vignettes where we were testing on variables that we thought would be likely to trigger people in terms of how likely they would assign responsibility or blame for certain kinds of traffic situations that cause some type of at least physical harm. So these are just examples of two of these vignettes here. What we were interested in is, does it matter to people if a single automated vehicle causes or is involved in a rear-end collision versus a convoy? Like, once you start to see multiple coordinated AVs moving down a highway or a stretch of road, and there's an accident that results from that kind of agent rather than just a single car, what are people's moral intuitions about that? How do they delineate responsibility? Do they do it differently? Would they assign it in a way that's not currently visible to the law or to states right now or to the market? And beyond that, how is that factored into whether or not the fleet is privately or publicly owned? In other words, is it just a company that's managing the fleet, or is it a municipality that's somehow sanctioning or controlling its behavior? And then thirdly, does it matter if the reason for these situations was that the car in question was just navigating traffic, or was it explicitly trying to control it? Was it explicitly trying to regulate the flow of how all these cars could move? And was that the reason, or in some way correlated with, in this case, a rear shunt collision, basically a rear ending situation? So there were other vignettes we showed people where we were controlling for each of these features and how they were correlated with each other. This is just a taste of how it was worded. And again, this work is not published yet, but my hope is that within the next couple months that will change. But I'm comfortable sharing the preliminary results of what this work is. So what we found was that convoys of AVs, so AVs that were operating specifically in groups of 5 moving down a highway, were perceived by people, and this is all statistically significant, I should say, like all this was significant and also geographically invariant, like it didn't matter where people lived or what their genders were or anything like that. They were perceived as less acceptable and were more likely to be blamed, or rather the organization that owned them was more likely to be blamed than if it was just a single automated vehicle that was involved in some kind of rear shunt collision. We also found that privately owned automated vehicles were also less acceptable than those affiliated with a public transit agency. I should say again, we don't necessarily know why people felt this way. Like that's going to be future work. We're going to investigate this further. My hypothesis is that it's something to do with the fact that if it's publicly owned, people tend to think there's a good reason, or some kind of like in the public interest for some reason. The fleet is operating accordingly rather than just for the sake of whatever the interests are of the private company that's owning it. But for whatever reason, there was a discrepancy there in judgment. And then finally, if the AVs were optimized to regulate traffic flow rather than just navigate, they were also blamed more than if they had this more passive stance towards traffic. Now, what's interesting as well is we got cross-tabular data between these things, right? So there were interesting situations where, for example, a private automated vehicle was more likely to be blamed than a publicly owned one, unless there were multiple ones. And again, we don't know why that is. We have some ideas about what people are thinking there. It could be something to do with the fact that people start to think that a public agency that is controlling traffic with multiple cars is somehow more dystopian or more scary than just a private industry that just also happens to have a fleet with such a capability to do that. We're not sure, but we are currently planning a follow-up study that is going to test on like more finely grained situations to see if we can suss out the reasons for why people have these different kinds of judgments. And also to see if there are different either places where people live or if there are different national or ethnic disagreements about these things, because we know from previous work that we know that those kinds of demographic features do tend to explain some of these discrepancies. But anyway, I'm very excited for when this work will be public, because I think it'll make a unique contribution to the literature, because to my knowledge, this is the first study that empirically evaluates how people assign responsibility for fleets distinctively.
The question.
Yeah, sure.
Question. Yeah, first of all, how this perceive how to say how do you measure this ratio? Like what is who was blamed or who was not? What is less acceptable? What is not? For example, did you provide sort of like preferences? For example, you have this situation. Which situation do you prefer more, or how?
Yeah. So we used it was like a Likert scale of sort of like how much do you blame either the human who's rear-ending the AV that's being hit, or the owner of the AV, where like we had different, and the owner of the AV could either be private or public.
So am I correct that you provided sort of like single situation, and how do you, for example, provide the score for such situation, or you provide like the preference? For example, you have here for example, the regulatory here the navigatory scene. Which scene do you prefer more? Is it was
Yes, that's right. Well, I think the way we constructed it was we showed lots of different people these different situations. And so for each situation, they were asked, who do you assign the greatest responsibility to? And of the people you assign responsibility to, how much were they blamed? Like how much blame do you put on them for it, right? And so that's
I see it's combined sort of what is the preference and then what is the score of this preference,
yes,
sort of.
yes.
And also the question is can you please switch to the previous slide?
Yeah.
Yeah. Did you provide like the examples for this human trash using like images or how to say
Yeah.
descriptions in text or like real
Yes.
real damages on the road like photos or videos?
So we discussed this because this has been done. There has been previous work on how people respond either to video or photographs versus vignettes. For a variety of reasons, we chose vignettes.
Yes.
This is another thing that I think future work is going to have to investigate because, as you note, there is a difference between these kind of highly stylized depictions of these cars versus like actual road. And actually, I'm going to discuss that. That's actually like a future work thing. But actually, it's good. It's a good question because actually, one of my concerns with these vignettes was I was concerned that if the AVs were yellow, people might subconsciously associate them with taxis or something like that. And that might somehow affect how they judge these things. But because a study like this is new, like no one's investigated this before, we're just like, well, the plus side of that is we can just do future studies that just change the colors or just sort of see all these different things. So this study had many limitations, but like these kind of results, which I can also share the draft of the paper with you if you're curious, but these are the first empirical findings to my knowledge of people given the option to distinguish how they assign responsibility for different capabilities in terms of the scale of the fleet, in terms of who owns it, in terms of the purpose of the fleet. So it's really just meant to be the first stab at those questions themselves rather than even just the data. And just to remind us, I'm happy to take another question later to finish this part. So just to remind us of this wider vision here, explicitly for me, the goal was to take capabilities that we were doing in the first paper, trying to build in, and then empirically give people like the behaviors that you would expect to manifest from those constraints, and then ask them to interpret them, ask them to assign responsibility. So for me, this is the wider vision, is it's not just that you do these things in parallel, is that you deliberately test on the variables that you've previously managed to simulate or encode and show them to real people in a way that then sets you up for the next study, that then sets you up for the next element of the loop, the next side of the translation. So that's where we're going, is we're actually going to go back around the loop again based off of these findings. But you had a question, Sarah.
Yeah, I was wondering why you chose blame as this metric to survey against. That seems very based on like a punishment culture when there's like you want to attribute blame to like a single component when there's what there shows like in difficult situations, there's multiple factors that have contributed to the inducing scenario. So why focus on just that blame attribution?
So I agree with you. This was a debate that I had with my co-authors about what are the other things we could ask people about. So for example, you could imagine a different version of this study. Actually, it would have been better maybe if I put undesirable fleet behaviors at the end, something like that, right? There's another version of the study where we showed vignettes of like, here's all the great things that this fleet could do. How do you assign responsibility or benefit or, credit rather than blame, right? That would be another study. Yeah, that's completely valid. The reason we did blame was frankly primarily because there's been so much work on how people reason about the ethics of automated vehicles in terms of blame, in terms of like assigning responsibility for negative things, that it was the way for us to just be in closest conversation with existing work. Given that what we were asking was new with respect to fleets, we were really just trying to anchor it as much as we could in how do we translate these kinds of questions and concepts that many researchers have already been interested in, but actually do it at the fleet level. But I completely agree, and this is another thing. Not to defer your question, but like the next study should literally be like, once these efficiencies are unlocked, how do you get this stuff? But even beyond blame and credit, there's other stuff you could ask about too. Any other questions so far? Okay, then I'll keep moving. Okay, I do see a hand raised.
Yeah, I just had maybe also for future studies, but I was wondering why we have or you thought of that distinction between private owned versus public agency owned, and I that also got me thinking maybe another interesting kind of division or comparison could be among the AV vehicles. Like I'm curious, instead of just comparing between human cars versus AV cars, what if there's a collision between different private owned AVs or something like that, right? So is there any difference in perception?
Yes, that's a great question. I completely agree. Yeah, I don't have much to add there. That is a very good question, because again, that's very philosophically germane to what I'm trying to do, which is you think of what these fleets are as recombining the components of a transit system. So rather than just asking, well, how do you assign blame to that new component? It's how does that component reconfigure the relationship between all these other elements, other road users, new kinds of fleets that are interacting with each other, whatever features you're concerned with. So that would be another example of what a future study could do, and maybe also cross-referencing that with the behavior of convoys, right? So if a convoy if two convoys are moving down a highway, for example, and one is dominant over the other, or somehow there's a rear shunt collision resulting from that, how is blame assigned, right? You have to find a way to get the problem. In many ways, the bottleneck here is that the public has not yet been invited to deliberate about these questions. A lot of this stuff remains, like a lot of the stuff I'm saying to you guys, you understand because you work at a company like this, but most people are not used to thinking of fleets as agents that are distinct from individual cars, right? The fact that a fleet has qualitative affordances that are distinct from just individual human drivers moving down a highway is so far removed from people's intuitions that a lot of work went into just our design of these vignettes to make it like starkly clear to people what it feels like when a convoy or a platoon is moving down a lane rather than just an individual car. It's actually you have to really finesse these vignettes to make it so you can even measure the effects that you want. So again, this is a great topic for a future version of the study, a different kind of a survey.